Alright, welcome to videos for this week. We're going to discuss curl, something that we've kind of already talked about way back in like Calc 2s at some point. But we're going to look at it more in 3 dimensions now and also think about kind of the physical context too. So just as a warm-up here, I want you to think about this vector field here and pretend, or I guess imagine that it represents fluid flow. So again, the longer vectors means it's a stronger flow versus the shorter vectors is a less strong flow. And then so if we fix the center of each of these points here, so these plus marks, so that is literally like we put a dot in the middle. I want you to think about which direction they would rotate. Alright, so resume the video when you kind of have an answer. Okay, well, I think if you can imagine this, at least for this upper left one here, the force along the top is going to be the fluid along the top is going to be flowing faster or more strongly than the fluid down below. So eventually, if this point is fixed, there's going to be some rotation kind of counterclockwise. Okay. Similarly, and I missed the center on this one, but if we imagine on this same one down here, the bottom is going to be rotating faster than this, or the bottom is going to have more force associated to it than the top, so it's going to be rotating clockwise as well. Okay, so there's this even within a vector field, if we put an object in there, we could have some kind of microscopic rotation. Okay, and so we did it in 2D, and then similarly in 3D we might have a vector field. So we would look at balls around a point, and so here we would see it would be spinning along some axis. Okay, and then so this is all. So that's kind of a large overview of what curl is going to be, but we also want to think about the curl perhaps as an operator. We've seen a lot of operators before. We've seen dt of g of t, so this just means really take the derivative of g of t with respect to t. Dt or ddt just means take the derivative with respect to t. This so the gradient of g of x of y, doesn't this just mean literally that we do the partials and put them as kind of as ordered pairs, or ordered triples in this case? So dg, dz, okay, and then really what this means, when we think about it, at least in our past use, we think of this as the partial with respect to x, the partial with respect to y, and the partial with respect to z of whatever we're doing. And so here we're actually going to call this the del operator. Okay, and so I have used that language before in class, but formally that's what we're going to call it. Okay, so then just as a quick example, here also just remembering the cross product. To do the cross product, we end up doing a determinant. We do I, j, k, and then we do the first vector, so 1, 2, 3, and then 4, 5, 6, and then you can check my work, but I ended up getting -3, 6, and 3. Okay, now we did this with 2 vectors. What if we're given a vector field? Okay, and we're doing the gradient cross this. Well, how can we do this? What does it mean? Well, let's do it mathematically and see what we get. Okay, so if we do the gradient cross f, this is going to be the same as, okay, I, j, k, and then m, n, p. I'm sorry. First vector, which is the gradient, so del x, dd ddz, and then m, n, and p. Okay, and now to save my hand some agony and yours as well, I'm going to just do subscripts for the notation here. So in the first component, I should have p sub y minus n sub z. Okay, so that means partial of p with respect, or partial of p with respect to y, and partial of n with respect to z. And then the next one, there's going to be a minus sign, right? And then we'll eventually factor that in, but it should be p sub x minus m sub z. And then the last component is going to be n sub x minus m sub y. Okay, and that maybe looks a little familiar. Okay, and so now what does this mean? Well, that's where we get into this in the next video. But we will see this sort of the del across a vector field f in many future videos. All right, so stay tuned for the next video.